Let's look at OpenStack's College Physics Chapter 23, Problem 105. An LRC series circuit has a 200 ohm resistor and a 25 millihenry inductor. At 8000 Hz, the phase angle is 45 degrees. A. What is the impedance? B. Find the circuit's capacitance. C. If VRMS is 408 volts is applied, what is the average power supplied? So, let's write down the knowns and unknowns. We know that the resistance is 200 ohms. We know that the inductance is 25 millihenry. We know that the frequency is 8000 Hertz. We know that the phase angle phi is 45 degrees. And in part A, we're looking for the impedance, so that's Z. In part B, we want the capacitance. In part C, knowing that VRMS is 408 volts, we're looking for the average power. All right, so we're looking for the impedance in part A. Now, the equation for impedance has resistance, capacitive reactance, and inductive reactance in it. Well, we don't know the capacitance, so how do we figure out what the impedance is? How about we draw the phasor diagram? So remember that the current, for some reason, we draw in the first quadrant, and then we express the voltages in the resistor, inductor, and capacitor in terms of that current. So we know that the voltage across the resistor is in phase with the current in the circuit, so this will be V sub R. We know that the voltage across the capacitor lags the current, so this is V sub C, and we know that the voltage across the inductor is ahead of the current, so it leads the current, and these angles are supposed to be 90 degrees. They are not in my picture here, but that's what they're supposed to be. So now we treat these red arrows as if they were vectors, so I'm going to subtract from VL, VC because they are along the same axis, and that leaves me with this quantity, which is VL minus VC. So I complete this rectangle, and that will be the voltage in my circuit. Now this is the phase angle. That's the 45-degree thing that they gave us. So if I look at the quantities we're given and do the trig, then I see that the cosine of phi is going to be the adjacent, so that's V sub R divided by the voltage. Now the problem is that I don't know the voltages and I don't know the currents, but the current is the same through all of the different components. So when I write that my voltage is square root VR squared plus VL minus VC squared and divide both sides by the current, then I have impedance is square root R squared plus XL minus XC quantity squared. So what that means is that when I do the trig here, instead of V sub R, I can use R. Instead of V, I can use Z. So I can say that cosine phi, that's for part A, is R divided by Z. And I know R and I know phi, so I can solve for the impedance, and that will be R divided by cosine phi. So that's 200 ohms divided by cosine 45 degrees. And that gives us 283 ohms. Now, I have the impedance. I have this part. And I'm looking for the capacitance. So I can use this equation and solve for the capacitance. So part B, I'm going to square both sides of that equation. I'm not going to copy the equation over. So I have Z squared is R squared plus XL minus XC quantity squared. That means that XL minus XC is square root Z squared minus R squared. So that means that X sub C is X sub L minus square root Z squared minus R squared. X sub L, the inductive reactance, is 2 pi times the frequency times the inductance, and then from that we subtract Z squared minus R squared. So let's plug the numbers into the equation. We have X sub C is 2 pi times 8,000 hertz times the inductance, which is 25 times 10 to the negative 3 henries, minus square root Z we just calculated, so that is 283 squared minus 200 squared. So we get a capacitive reactance of 1057 ohms. Now we know that X sub C is 1 over 2 pi frequency times capacitance. So the capacitance will be 1 over 2 pi frequency times capacitive reactance. So that is 1 divided by 2 pi. Frequency is 8,000. And X sub C is 1057. And we get 1.88 times 10 to the negative 8 farads for our capacitance. Now in part C, we're looking for the average power. So average power is IRMS VRMS times the power factor, cosine phi. I don't know IRMS, but I can use Ohm's law and say that IRMS is VRMS divided by the impedance, and we multiply that by VRMS times the power factor. So P average is going to be VRMS squared, which is 408 squared, divided by the impedance, which was 283 ohms, and power factor is cosine 45, and we end up with 416 watts.